Hi, my name is James Grinde. Currently a student at the University of Arizona Global Campus. This is for Psychology 7510, Biological Basis of Behavior, taught by Dr. Raymond Daniel. Uh, Introducing the topic in the thesis is we're going to explore the inner workings of the proprioceptive system. There is a significant value in exploring the proprioceptive system, particularly for researchers, healthcare professionals, educators, and the general public. Understanding the intricacies of this system offers several compelling reasons for its importance. One of those reasons is enhanced therapeutic interventions. Another is better physical and mental self care, which is often overlooked, which is key to getting better at self awareness and understanding one's body, movements, and limits. And then there's been advances in human movement sciences for researchers, studies, and studying the proprioceptive system opens doors to breakthroughs and in depth research in human movement sciences. In essence, exploring the proprioception system is not only crucial for healthcare providers, individuals' well being, and understanding other cultures, but it also facilitates a deeper connection between the brain and the body. It serves as a catalyst for advancements in research, healthcare practices, and education, offering a total, overall, comprehensive understanding of vital aspect of human physiology. The value of studying this and understanding the intricacies of proprioception, it provides us with valuable insights into the broader context of human biology. The integration of sensory information, including proprioception, is a dynamic and intricate process that involves the brain, nervous system, and various physiological mechanisms. The intricate dance between neurons, neurotransmitters, and specialized receptors showcase the complexity of human biology and the remarkable ways in which our body functions. So, the identification of the proprioceptive system, its name and location is the proprioceptive system, primarily located in the muscles, joints, and tendons. It is responsible for sensing and providing information about the position and movement of our body parts. Basic anatomy is within the key anatomical structure include proprioceptors in muscle, joints, capsules, and Golgi tendon organs working in concert to relay information about body position and movement. Neurobiology of the proprioceptive system and neurons and the neural pathways. Proprioceptive neurons, primarily type 1A fibers, transmit information to the spinal cord, creating afferent pathways vital for proprioception. Neurotransmitters are within the system that rely on the neurotransmitters like glutamate to transmit signals, facilitating communication between neurons and ensuring accurate proprioceptive feedback. And then the brain regions that are involved, the primary somatosensory cortex and cerebellum play crucial roles in the processing the proprioceptive information, contributing to our overall body awareness. Here we can see the monosynaptic circuit and the polysynaptic circuit, where proprioception at the neural level connects both sides of the brain, where the muscle spindle and the spinal system connect. So to the left there, you can see the skeletal muscle, the muscle spindle, which is the fibers within, and then the group 1A muscle fibers, which then turn into alpha MN, and we get a presynaptic neuron, which then connects us to the cutaneous group of 1A, type 2, and type 1B fibers. Functions of the proprioceptive system. So, its primary function, it's one of the many sensory systems in our body, and it allows us to sense our body parts. And its function It aids in the precise control of body movement, and it works synergistically with the visual and vestibular systems, where proprioception ensures a harmonious integration of sensory inputs, contributing to the overall homeostasis of the body. Here, another example where the muscle spindles and the proprioceptors in the muscle are long proteins that lay parallel to the muscle fibers. As we can see here, we have sensory nerve endings which control the muscle fiber, which, when looking back at our previous image, we look at the synapses where they all connect, and the type 1 fibers, which are the muscle fibers, connect with the sensory nerve endings, which connect with the muscle spindle sheath. All in all, these muscle fibers, muscle endings, and muscle spindle sheaths connect to make the muscle move. Social consequences and the impacts on daily life, work, and other relevancies. The proprioceptive system significantly influences daily activities, from simple tasks like walking to more complex activities requiring fine motor control, such as playing pickleball. Disruptions in the proprioceptive system, as seen in conditions like apraxia, can impact individuals' lives, affecting their ability to imitate and perform purposeful movements. Treatment options often involve proprioceptive-based interventions. And then if we take a look at social and cultural implications, proprioception plays a role in the cultural practices and social behaviors, influencing how individuals navigate and interact with their cultural and social contexts. Here we can see proprioception at work. We're holding a bag, and our bicep tendons are, and our bicep femoris is extended here, or flexed, excuse me. Sudden weight changes cause muscle to extend. So if someone's throwing a ball into our bag, or an orange or heavy oranges into our bag, then the muscle spindles trigger as a reflex to maintain tension in the muscle. In conclusion, the proprioceptive system is a cornerstone of our sensory experience. The proprioceptive system influences extend beyond physical functions. A deep understanding of proprioception not only maintains physical health, but also holds a profound implication for mental and emotional well-being, and specialized receptors in highlighting the intimate connection between mind and body in the complex dance of human biology. Some proposed research questions and follow-up questions in the area of anatomy and proprioception. What are the in-depth neural mechanisms that make fine motor movements so precise and coordinated? How can this information on how our body learns to play a role in therapies? And then from a cultural and variances and proprioception standpoint, how do cultural practices and societal norms influence our proprioceptive awareness and utilization? Do cultural differences in proprioceptive acuity exist? Is there a bigger acumen when understanding cultural differences? But what about cultural differences in how we use proprioception each day? How might we incorporate cultural differences and considerations in developing rehabilitation strategies or interventions for conditions impacting the proprioceptive system? Theoretical implications and answering some of those questions. Human movement sciences explore the coordination of fine motor skills, mechanisms involving muscles, open and closed chain motions, type 1A fibers for proprioceptive information transmission, and glutamate receptors for orderly message signaling. Insights into how the body learns, adapts, and processes proprioceptive information, as emphasized by Isaacs et al. In 2022, have significant therapeutic implications. Understanding the neural basis allows for targeted interventions to enhance Proprioceptive function. Incorporating cultural dimensions in designing rehabilitation strategies for proprioceptive conditions is vital. Tisari and Ottoboni in 2022, as well as Freberg in 2024. Perceptions and the uses of proprioception across cultures may necessitate individual interventions that respect and incorporate cultural differences.